Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us begin solving this step by step. Count the total carbons in the structure. The molecule shown has a terminal alkyne on the right side, vinyl allyl type, a chain, a CIS double bond, and a butyl chain on the left. Counting all carbons, HCCCH2CH2CH is equal to CHCH2CH2CH2CH2CH2CH3, that gives 12 carbons total, so the parent chain is dodecane, dodec. Moving on to the next step. Identify the functional groups. There is a terminal triple bond, alkyne, and an internal double bond, alkene. The compound is therefore an anion. Moving on to the next step. Number the chain to give the principal characteristic group, or the first point of difference, the lowest locant. The terminal alkyne is at C1, C2, since alkynes get lower numbers when in conflict with alkenes per IUPAC rules, and here numbering from the alkyne end gives triple bond at C2 and double bond at C6. Numbering from the alkyne end, C1, C2, C3, C4, C5 is equal to C6, C7, C8, C9, C10, C11, C12. And for the final step, assign the double bond geometry. The double bond is between C6 and C7. Looking at the drawn structure, the two higher priority groups on each carbon of the double bond are on the same side, CIS, which corresponds to Z configuration. Dodecane dodec. Triple bond at position 2-2 Yane. Double bond at position 6 with Z geometry, 6Z, 6N. Combining 6Z, dodec 6N, 2 Yane. Verify. The structure is HCCCH2CH2CH is equal to CH, CH2, 4, CH3 where the double bond at C6 is Z, CIS, and the triple bond is at C2, terminal. Total carbons is equal to 12. Name is equal to 6Z, dodec 6N, 2 Yane. Therefore, the correct answer is 6Z, dodec 6N, 2 Yane. The correct answer is shown on screen.